In object-oriented programming, we are taking question and answers. What is polymorphism? Polymorphism, there are two words here. This is a Latin word. So it has come from poly and morph. Poly means many, morph means shape. For example, if I tell you a word, write, you can write it like WRITE, or even you can understand RIGHT. Generally speaking, when we are talking about the programming paradigm, the polymorphism means that a method or function is able to cope up with different types of input. So polymorphism is the ability of the message to be displayed in more than one form, depending upon the situation, depending upon the scenario, depending upon the invocation. So in C++, polymorphism means that a call to a member function will cause a different function to be executed depending upon the type of object that is calling that function or invoking that function. So polymorphism can be of two types. It can be a compile time polymorphism. It can be a runtime polymorphism. The compile time polymorphism is implemented in two ways. Let me tell you, compile time is early binding, runtime is late binding. So in order to implement the compile time, we have function overloading and operator overloading. Similarly, for late binding or runtime, the method overriding is done, and this is implemented using the virtual functions. So this is, I am telling you about the compile time. So we have a class here which is called figure. Now we have three functions here. Now these functions, this class object is being made geo, and this geo.area, 3 times this area is being called. Now the name of the function is same. This is called polymorphism. That is, name is same, but depending upon the input. If you give 7.0, it is going to call this middle function. When you pass 2, 3, that is integer, it will call the first area function defined in the class. And when you call third area, that is going to call the third function in the class, which is having 2 double values as the input. What are types of polymorphism? Example of runtime and compile time polymorphism. First thing is, polymorphism is what? One phase different acting. That is, one word or one function doing different work, performing different work depending upon the invocation or depending upon the calling or scenario. Polymorphism has come from two words, poly and morph. Poly means many, morph means the faces or shapes. So it can be of two types, compile time and runtime. Compile time is also called as the early binding. Runtime is also called the late binding. The compile time or polymorphism is implemented by function overloading and operator overloading. The late binding runtime is implemented through virtual functions. So I'll give an example of that. First of all, the compile time polymorphism we are taking. This is the example of function overloading. Now we have a class here. The class name is figure. We have declared and defined 3 functions here, and they have the same name. This is very important. Same name. Inside main, we have created an object of this figure class, which is called geo. Now this geo is invoking the function, but it is invoking same function, area. The names are same. But depending upon the input type, the parameter type, the object is calling different functions, and this is called the compile time or early binding. This is an example of function overloading. Depending upon the different situation, it is behaving differently. Function is. Now taking an example of runtime or late binding, this is virtual function. For this, we need inheritance. This can only be possible when you have an inheritance kind of situation. Okay. Inheritance says you have a base class. Now this base class has a function called print. Similarly, we have a derived function, and the function has also print. But this derived class is derived from where? From the base class. That is, derived class is inheriting the base class. So we have a derived class, and this derived class is inheriting the base. So this is a relationship. So derived is a base. Okay. Now both of them have a print function. Same function, nothing, no difference. Same function. Now when we create an object of this derived class, we pass a reference of this derived object to the base pointer, and from base pointer we are calling the print function. What should happen? To be very honest, it should call the derived class, the print function, from what we see here. But the situation or the problem is, it will not call the derived print function. There will be an error. That is, why we have done this ampersand derived? Because we have passed it to the base, and then base is calling the print. So we have actually tried to call the derived function, the print function of the derived class, but this won't happen. For that, you need to do what? You want to force that whenever I do this, I want to call the print function of the derived class. Actually, it is coming from the base class. The base class is always giving that function from this kind of code. Okay. The solution is, what is the solution? The solution is, if we want to get the derived function, the same name, please remember the names are same, then we have to write virtual. Give a real world example of polymorphism. Polymorphism is one phase, different acting. One thing doing different kind of work. The general meaning of polymorphism is one that have different forms. Just assume a person playing different roles. A person at home can be a father, can be a husband, can be a son. So different role he is playing. Single person. The same person, when he is in office, he is acting like boss or an employee. When he is traveling in train or public transport, he is a passenger. When he is in hospital, he is a patient or a doctor. In a shop, he is actually a customer. So a single person is behaving, is acting, is playing all the roles whenever the situation demands, whenever this situation arises. The person, they see, just assume that this role is a function or a method. So this person is playing different role as a father, role as an employee, role as a husband. So same role, this role function will be connected to employee, father or husband depending upon where he is. Is he in the office? Is he in the house? Or is he in the public transport? The same person possesses different behavior in different situation, and this is a very good example of polymorphism. Now we have a class here, class name is figure. Now we have three functions, same name, there is no change. This is very important in polymorphism. The name are same. But when we make the object of this class, which is called geo, and we are calling area, the names are same, area. Now, which is going to be called? Which function is going to be called? And this will be decided in the compile time, that whenever you pass the integer, it will go to the first function. Last, both double, it will go to the third function. What is the difference between composition and inheritance? Now, see, inheritance means what? Inheritance is all about reusability. It is a relationship. That is, a house is a building, or you can say building is a house. There is both a relationship. But just assume that something is a bigger set and something is a smaller set. So, if I am the son, I inherited the property of my father or money of my father, then I am inheriting. So my father is my base class and I am the derived class. So derived always is extended from base. Base is the base class. So derived class will inherit base. Also, it can provide its own function data variables. This is the inheritance. Now coming to composition. Composition, let us understand with an example. We have a class A, then we are making a class B. Now we have a class C, and we have an object of class A. We can make a class an object, that is A obj1, and we can make an object of class B also, B object 2 obj2. But now you see, these two objects of two classes are the member variable of class C. So now class C has A, class C has B. When a class is referring to other class with respect to their objects, it is called a has a relationship. Okay, so inheritance is a relationship, composition has a relationship. Composition means that an object holds other object. Inheritance, there is only one object in memory, that is a derived object, whereas in composition, the parent object holds references to all composed objects. For example, take car and an engine and Honda. Now, Honda is a car. Honda is a car. So Honda is the derived class, car is the base class. Okay. So Honda is derived class, car is the base class. The car has an engine. Car has an engine. Every car has an engine. So this is a has a relationship. This is the difference between composition and inheritance. So the inheritance is all about inheriting, or say base and child relationship, but the composition is referring to other class with taking their objects. So class Honda, you can say class Honda colon car. So class Honda is a car. So this is the inheritance relationship. What is constructor chaining? So one constructor calling another constructor, in turn that constructor is called another constructor. So chain is what? Chain is like this. One is connected to another, the other is connected to another, like this. This goes around and on. So constructor chaining is when the constructor calling goes on and on. So in object-oriented programming, constructor chaining is a sequence of invoking constructors or calling constructors of the same class upon initializing an object. When you initialize the object, number of constructors are getting called one by one. It is used when we want to invoke number of constructors, one after the other, by using only one instance. That is, when we are making an object, we are not interested in calling constructors one by one. We are just saying that let me call one constructor and let that constructor call the other constructor one by one. So if a class has more than one constructor that is overloaded and one of them tries to invoke another constructor, this process is known as constructor chaining. In C++, it is known as one more name is there. It is called as constructor delegation. Constructor chaining is also called constructor delegation. It is present in C++ from C++11. Okay, take an example. Here we have a class called student, and since we have three constructors here, you can just recall that the name of the constructor and the class will be same. So now this is a default constructor, nothing is given here. Now we have a constructor, we have you can say we have defined it. So you have an input which is string, and now we have this here, this call itself. Okay, now we have another constructor which has one string, one integer. Again we have this here. So whenever we create an object, we have created an object here, student. So we have created an object of our class, and we have passed two parameters, one is string, one is integer. So where it is going to go? It is going to call the constructor by itself. New operator will definitely call a constructor. So this will be called. All the work will be done, all the instruction will be executed, but the last is this name. So this means it is going to call the constructor, but what is the parameter? Name, string. So it is going to call the constructor which is shown just above, this one. Now again the instruction will be executed. Now at the last we have this. So it is going to call constructor with no parameter. So it is going to call default constructor. So this is how the chain is formed, and chain of constructor is formed. That is why it is called as constructor chaining or constructor delegation. what are the limitation of inheritance? See, inheritance is all about reusability. So we have a class, two classes. Class B is inherited from class A. So class B is inheriting class A, right? That is, class B is a son, class A is a father. So son is inheriting the property of father. So see here, multi-level is there. Class B is inherited from A and class C is inherited from B. So here hierarchical, class B and class C both are inheriting class A. That is, they both are taking the properties of class A. Properties means data function members which are protected or public. So this is the inheritance, but what are the limitations? This is a very reusable. RY I have written for reusability. This is a very good example of reusability. But the disadvantage of using inheritance is that two classes are now tightly coupled. One is dependent on another. That means one cannot be used independently of other. When you talk about design, what do you want? You want low to low coupling. You want high to high cohesion. So when we talk about two class, we talk about the coupling. So if a method or aggregate is deleted in the superclass, we have to refactor using the method in the subclass. That is, class B is inheriting class A and it is taking all the function and data variables which are public and protected. But what happens if class A is deleted? Class B, you have to refactor it. Or what happens when the function of class A is deleted? That function has to be refactored in class B. And inherited functions work slower compared to normal function. Normal function is just like that. Here we have to first there are different levels of control flow. So the control flow or the control, you can say passing is too high here. So we need to be very careful about implementation. Otherwise it will have improper solution. So we cannot change implementation inherited from parent class at runtime. This is the disadvantage. And parent class often define at least part of their subclass implementation. There is always some part. So what is encapsulation? Encapsulation is having the code and function together. So when you are inheriting, you are actually going away from the object-oriented paradigm, because inheritance is what? Inheritance is taking the code and function of the above class. When you're taking you can access code and function of other class. What is about the encapsulation? So the best is to make an abstract class. Don't give any kind of implementation here. Just give the definition and implement that function. Implement that function in your derived class. What are the differences between inheritance and polymorphism? See, they both are the basic building block of object-oriented paradigm. These are the concepts and object-oriented programming languages they implemented using different constructs. So, let us take one by one example or differences. First is inheritance is that concept in which a derived class inherits the already existing class. For example, a class A is having data and function. Class B is inheriting class A. That means it is inheriting data and function of class A. So you can say that class B has class A inside it. Okay. See here also multi-level. A is inheriting B is inheriting C is inheriting B is inheriting A. So now C has A and B both. Polymorphism is that one name and different word, one function acting and performing in different scenario in a different way. So polymorphism is one that you can define in different forms. A person can play a different role. So depending upon the parameter in this function role, it can be a father, it can be a husband, it can be an employee. Depending upon what are the parameters you are giving inside this role function. So it will play a different role. The function will remain same. It will be a role only. Polymorphism, let me tell you that we have two types of polymorphism, runtime polymorphism and compile time. This I just told you about the compile time. Runtime, you have to do the virtual function kind of thing. and that is only possible when the inheritance scenario is there. Okay, inheritance, it refers to using the structure and behavior of a superclass in a subclass. I just told you when we inherit, that is when you inherit your father's property, you have all the property. So you are actually having his property in your pocket. So the polymorphism, it refers to changing the behavior of a superclass in the subclass. That is, polymorphism is all about changing your word depending upon the scenario. For example, you are making a class here. Okay. Now class B, and now you have inherited class A. So now you have a function, say fun and fun, both have function fun. Now when you write a main function and going to call, it will always be calling normally the base function, that is the base class function. If the function name are same, so you have to make this function as virtual, not the virtual class. I am saying virtual function you have to write. Then only the derived class function can be accessed. So this is called runtime polymorphism, and this runtime polymorphism is achieved by method overriding. That is why we have the implementation of this fun function in your derived class. Okay, inheritance, it is required in order to achieve polymorphism. As I just told you the example, that polymorphism is only possible when there is an inheritance scenario. And polymorphism, in order to achieve polymorphism, inheritance is not required, for example. Okay, inheritance is applied to classes. See, inheritance is applied to classes. We are talking about two different classes. But what about polymorphism? Polymorphism is applied to functions and method. So inheritance, it can be single, hybrid, multiple, hierarchical, multipath, and multi-level inheritance. There can be different type of inheritance. What about this is different kind of multi-level. I'm just explaining you. We have hierarchical also. So polymorphism, there are two types of polymorphism. Just now I discussed. This is the runtime and the compile time. So runtime and compile time, it is runtime is also called as the late binding. Compile time is also called as the early binding. So compile time, you can implement it using function overloading or operator overloading. Runtime is method overriding. Inheritance, it supports the code usability and reduces the line of code, because it is all about that. You are inheriting the code, so you don't have to write that code again. When class A is inside class B, and in the multi-level the class A and B is inside class C, that means you are actually taking the code. So the kilo line of code will be less. In polymorphism, it allows the object to decide which form of the function to be invoked at runtime, that is overriding, and compile time, which I just told you about, overloading, operator overloading, or the function overloading. So depending upon the scenario, the function will be called, and depending upon whether you are using virtual function, the base class or the derived class function will be called. What is coupling in object-oriented programming and why it is helpful? Now let me tell you about an example here. This is a class A. Just assume that all these functions are related to email. Check email, validate email, send email, like this. All functions are related to email. Now this is so good. A class A functions are like-minded. They are doing the work they are supposed to do. They are only working for the case of email. They are doing nothing else. This is called a good cohesion, a tight cohesion. But now somebody does like this. Class A, he wrote check email function here. In class B, he wrote validate email. Now the problem is, when I create the object of class A and object of class B and object of class C, now for example, if I'm saying object 3, I want to send email. Just assume that before that it has to be validated. So object 2 and object 3 became very close. So the object 2 and object 3 can change one another behavior. So that this is the object can directly change the state and behavior of object. So here left you see high cohesion, Here we have low cohesion and more coupling, tight coupling. And this tight coupling is not advisable. Cohesion should be high. Cohesion is only about a module or a class, but coupling is between two module or two class. So if the objects are closely coordinated, they are changing themselves, they are interacting, they are message passing, then the coupling is too high. But the cohesion should be low, high, and coupling should be low. Let me tell you again. If there are two objects or two different classes, and when they are interacting too much, they are changing their behavior of another. That is called high coupling, which is not, or tight coupling, which is not required. This is more dependency, more coordination, more information flow. We don't want that. We want loose coupling, less interdependency, less coordination, less information flow. So coupling is this. And how it is helpful? I told you about that. Name the operator that cannot be overloaded. So which are these? See, there are only 5 in C++. I'm talking about C++ 11. Okay. So we have scope resolution operator, two colon. Then we have ternary operator like question mark and a colon. Then we have a member access or dot operator, which is dot. Point to member operator, that is this dot star, and size of operator. These C++ operator that cannot be overloaded and other which can be overloaded are given here in this table. What is cohesion in object-oriented programming? Now let me give an example here. See, this is a class. Just assume that this class is doing everything related to email. All these functions, check email, validate email, send email, and all others, they are working only for email. So now these functions are closely related. They are like-minded. They are doing only the work for email. That is, this particular class has high cohesion, very good cohesion. And that is what we want. We want a module or a class to have high cohesion. Everything should think together and for a single goal, like single-mindedness. Now what happens? Somebody did something differently. He made a class A and placed check email. He made another class for validate email and another class where he put this send email. Now you see, when if somebody wants to send mail, or the mail class has to be accessed. Previously, class A was very good. But now when we have different classes having different functions of mail, when we make the object, these objects are going to interact. They are going to collaborate. They are going to be interdependent. And that is not good. Now this is called coupling. When we talk about two different classes, the interaction collaboration is the coupling. The information flow is coupling. So coupling is high. And we don't want that. So we want the coupling to be as less as possible, as low as possible, and the cohesion within a single class should be very high. So cohesion is the property of a module of a class. It is not talking about more than one class. Coupling is minimum of two class, of two objects or two modules. So cohesion, as I said, cohesion refers to the degree to which elements inside a module belong together. They are single-minded. They are working together for a single task. They are designed and made to do a single work, or the work which the class wants to do. Okay, and different classes means different responsibility, different roles. So every class should have its own single role. But when we talk about inside the class, all the function data variable, they are highly working together. So we say they are highly cohesive. But when we talk about two different modules, two different class, two different objects, when they are talking together in a very high manner, that is, they are collaborating, they are messaging, they are changing behavior in state, that is, the coupling is high, that we don't want. We want as less as coupling. But if two objects or two modules, they are not passing anything, or they are just sometimes they are interacting, then this is low coupling, and that's what we want. Okay. So this line which I'm showing is a coupling line. How high this line is, that is the design is not good. And coupling should be as less as possible. And cohesion, high cohesion is associated with robustness, reliability, understandability. Low cohesion, that is difficulty to maintain, to test, to reuse, to understand. So high cohesion often associate with loose coupling. Okay, this is all about this discussion. Thank you so much.